Now, see, in the previous class, what we have done earlier, show that these 3 points are collinear. And to prove any 3 points as collinear in two-dimensional geometry, what do? We find the area formed by those 3 points and make it 0. Then I told you how to find the adjoint of a matrix. For that, you will be given with a matrix. Then find the cofactors of all the elements of the matrix and make a new matrix C. Find a matrix whose entries are the respective cofactors of matrix A. And then take the transpose of C. And the C transpose is what do we call? Adjoint of A. Yes or no? In a 2 by 2 matrix, I directly told you to get the adjoint, change the diagonal entries and change the sign of diagonal entries. 3 by 3 mein, there is no particular way. You have to specifically find all the cofactors and put their respective places. Then properties of adjoint mein, what we have done, that A into adjoint A is determinant of A into identity matrix is adjoint A into A. Then I taught you determinant of adjoint A is determinant of A square if A is a matrix of order 3. Then determinant of adjoint A is determinant of A if A is a matrix of order 2. Then we have done 2 or 3 questions. Now we'll proceed further. Any doubt up to this point? Anybody? Anybody who want to ask something? All right. So today again, I will stick to the properties of adjoint. Properties of adjoint. So I will again write the first property. If A is a matrix of order, say n, this is a square matrix, then A into adjoint of A is determinant of A raised to the power n minus 1 into I. That is, sorry, determinant of A raised to the power n into I, not even n, sorry, what I'm doing. A into adjoint A is determinant of A into In, and that is also adjoint A into A. This was the first property that I told you. Yes or no? Second one, determinant of adjoint A is determinant of A to the power n minus 1. I gave you even proof of this one. Yes or no? Third one. Adjoint of AB is adjoint of B into adjoint of A. So it is adjoint of AB is equals to adjoint of B into adjoint of A. That is reversal law of adjoint. And this can be generalized also. Say you have 4 matrix adjoint of A, B, C, D. So adjoint of D adjoint of A, B, C, D is adjoint D, adjoint C, adjoint B, adjoint A. Correct? Now, property 4. Now I start something really serious properties. If A is a square matrix of order n cross n, then adjoint of A, 2 times adjoint of A is determinant of A to the power n minus 2 into A. Determinant of determinant of a to the power n minus 2 into a. Let's see its proof. See, we know a into adjoint a is determinant of a into in. Now, replace a by adjoint a. So it will become adjoint a, adjoint of adjoint a, determinant of adjoint a into I. Correct? I replaced a by adjoint a everywhere. Got it? Now, let's pre-multiply both sides by a. So a into adjoint a, adjoint of adjoint a. Now, determinant of adjoint a will be determinant of a to the power n minus 1 into a. Now, what is this? This is determinant of a into in into adjoint of a. Now, divide by determinant a. So, what do you get? Adjoint of a is determinant of a to the power n minus 2 into a. Very, very important and good property. Correct? Is it okay, everybody? Once again, all right. See, this is the property that we are already aware of. A into adjoint a is determinant a to the power n. Now you replace a by adjoint a. So this will be adjoint a. This will be adjoint of adjoint a. This will be determinant of adjoint a. This in is as it is. So now I pre-multiply by a. So it will become a into adjoint a. This one. Then adjoint a is determinant of adjoint a will be determinant a to the power n minus 1 into a, which by which we have multiplied. Correct. So this value is what? This value is determinant of a into in is this. Now divide by determinant of a, it will become determinant of a to the power n minus 2. Correct? Have a look. Write down. This is tough. I'm telling you. Now, property 5. If you remember in the last class, we have been talking about like if I multiply by a matrix with a scalar k and I take its determinant, then k is getting multiplied in every row in case is in every element in case of matrix. But while finding determinant, it will come out from every column or every row. So if it is nth order matrix, so it will be k to the power n determinant of a because k will come out from every row. Now we already have adjoint of a is determinant of a to the power n minus 2 into a. Correct? Let us assume this is some ka. Now take determinant both the sides. It is determinant of ka. Now take k common, k to the power n determinant of a. Fine. Now k was what? Determinant of a to the power n minus 2 all to the power n determinant of a. n square minus 2n into determinant of A. Tell me if you understood it or not. Fine. Let us do a question. Let matrix A is 1, 2, 3, 1, 1, 2, where x, y, z belongs to natural numbers. If determinant of एक दो तीन चार adjoint of adjoint of adjoint of adjoint of A two to the power 32, 3 to the power 16. Then find the number of such matrices. Yes, how to do? Find it. Done? Anybody? Mahesh? Now see, first of all, let us understand this. So the property behind it is adjoint of adjoint of adjoint and so on adjoint of A determinant is determinant of A to the power n minus 1 whole square. Fine. While there were two adjoints, it was determinant of A, sorry, n minus 1 to the power K. What is K? K is adjoint repeated K times. Clear? So that means determinant of adjoint of adjoint of adjoint of adjoint of A. So it will be determinant of A to the power n minus 1 to the power 4. 4n minus 4. Determinant of A to the power 4n minus 4. Now, if you calculate the determinant of A, -4. Sorry? Yogendra, are you saying something? Well, determinant of A will come out to be x plus y plus z. So now the question is that determinant of A to the power 4. Please switch off your mic, Yogendra. One by 8. Got it? So it will be 3 to the power 4 into 3 to the power, sorry, 2 to the power 4 into 3 to the power 2. So it will come out to be 72. 144, sorry. 144. Am I correct? So that simply means x plus y plus z equals to 144. And the number of solutions will be 146 C2. Correct? Am I clear? Last but one step, this comes from PNC basically, that if x plus y plus z equals to n, the number of non-negative integral solutions will be NC2. Okay, x, y, z are natural numbers. So the answer won't be 162 C2. It will be, say, 3 beggars looking for 144 oranges. Give 1 orange to each. 141, 143. C2 is your answer. How exactly did it come? It's little difficult for you to remember as of now. Because ये थोड़ा सा, this is mostly related to 11th class PNC. All right. Now, inverse of a matrix. Yourself. Now, inverse of a matrix. So a square matrix A is said to be invertible if there exists a matrix B such that AB is identity matrix and that is also BA. AB is an identity matrix and that is equal to BA. And in that case, A inverse is equals to B and B inverse is equal to A. Understood? So A inverse is B and B inverse is A. Now, see the property. Just now we studied that A into adjoint A is determinant of A into I. Let's consider third order matrix only. So you can say A into adjoint A upon determinant of A is I, and that is also into A. Got it? That means if product of these two matrices, 1 and 2, is an arbitrary matrix and they are commutative also, then A inverse is adjoint of A upon determinant of A. A inverse is adjoint A upon determinant of A. Now, getting adjoint you already know. Getting determinant of A you already know. There is, in matrices, there is no particular process of division. Even there is no process of division. We can add two matrix, we can subtract two matrix, we can make a matrix multiply by a scalar. We can even multiply two matrices, but we cannot divide two matrices. We just call the reciprocals of each other. All right. Am I clear?
Sir.
So A inverse is adjoint A upon determinant of A. Now see, in a 2 by 2 matrix, in a 2 by 2 matrix, we know if A is A, B, C, D. Yesterday only I told you how to get adjoint A. Change the diagonal entries, change the sign of diagonal entries. Fine. So A inverse will be what? Divided by AD minus BC. This is what we call adjoint of matrix A. All right. Now see, A inverse is what? A inverse is adjoint A upon determinant of A. Now, if this quantity goes 0, you can never find adjoint. Yes or no? So, determinant of A should be non-zero for matrix to be invertible. Yes, determinant of A should not be 0 for matrix to be invertible. So, this is necessary and sufficient condition. Got it? So determinant of A non-zero for a matrix to be invertible means determinant of A non-zero means non-singular matrix. Fine. So for a matrix to be invertible, it should be non-singular. Next point. If we have matrix A If this is a matrix A, now this is a diagonal matrix. So A inverse will be what? A inverse will be 1 by D1 0 0 0 1 by D2 0 0 0 1 upon D3. Am I clear? Next. Now, if A is invertible, then A transpose is also invertible. And A inverse a transpose is A transpose inverse is A inverse transpose. Got it? Now next, very, very important. A inverse determinant is determinant A inverse. That is 1 upon determinant of A. A inverse determinant is determinant of A inverse, that is 1 upon determinant of A. Fine. So these are all the properties of determinant, inverse of a determinant mostly. Got it? Next, again very important. AB inverse is B inverse A inverse. It can also be generalized as ABCD inverse is D inverse C inverse B inverse A inverse. Now see, let's prove it. Matrix AB into AB inverse will be identity matrix. Yes or no? Now pre-multiply with A inverse A. So it will be A inverse AB, AB inverse is equals to A inverse. This A inverse into A is I. So it is B into AB inverse is A inverse. Now again pre-multiply by B inverse. Then you get AB inverse will be B inverse A inverse. That's it. Now a few more simple properties. A inverse will be A. Then A to the power K inverse is A inverse to the power K. Understood? Am I clear? Shall we do a few questions? Okay, write down a question. Simple, good question. Find the inverse of matrix A is A, B, C, 1 plus BC upon minus. Find the inverse of this matrix. Yes, quickly. What is the value of determinant of A? A times 1 plus BC upon minus A minus BC. So it is just a moment. Okay, this is positive sign. Otherwise, it will be very heavy calculation. So it will be 1 plus BC minus BC, that is 1. So determinant of A is sorted, it is 1. Fine. Now adjoint of A is what? In 2 by 2, change the diagonal entries, change the sign of off diagonal entries. Now A inverse is what? Adjoint A upon determinant of A. And since determinant of A is 1, the answer will be simply 1 plus BC upon A minus B minus C. Understood? Write another question. Find the inverse of matrix determinant 0, 1, 2, 1, 2, 3, 3, 1, 1. Yes. Give it a try. Quickly find the adjoint, then find the determinant, and then divide adjoint upon determinant. Quickly do, I give you 2 minutes. Yes, Tanush. Tanush.
Sir,
Ramaksha.
sir,
Are you finding the inverse?
yes, sir.
Tanush, are you also working on some doing questions from somewhere, practicing from somewhere?
No, sir.
And why are you not doing it? In the very first lecture, I told everybody that you can start with the NCRT exercises at least.
It's no question done.
See, all of you, now you can attempt all the exercises of NCRT. Only one exercise will be left, that is simultaneous solution of equations. Okay, that I will do in a while. Well, chalo, you will find it on your own. I just give you its answers, so match accordingly later on. I will teach you some new topic. It is 1 by 2 minus 1 by 2, 1 by 2. Minus 4, 3 minus 1, 5 by 2, minus 3 by 2, and 1 by 2. All right. Now, put a heading. System of equations. System of equations using matrix method. System of equations using matrix method. Let you have a system of equations a1x plus b1y plus c1z equals to d1. a2x plus b2y plus c2z equals to d2. And a3x plus b3y plus c3z equals to d3. All right. a1x plus b1y plus c1z is d1. a2x plus b2y plus c2z is d2. a3x plus b3y plus c3z is d3. So how to solve using matrix method? So first of all, what we do, we make a matrix this. a1, b1, c1. a2, b2, c2. a3, b3, c3. If it is multiplied by x, y, z, what you are getting? d1, d2, d3. Yes or no? This is how we can write the equations in the matrix format. Now let us call this matrix as x, ax equals to b. So if ax equals to b, can I say x is a inverse into b? That is adjoint a upon determinant of a into b. This is your matrix x. So once you get this, just compare with the xyz values, you get the values of xyz. Am I clear? Fine. Now, let's solve a question. Simple question I will do first of all. X plus y plus z equals to 1. 2x plus y minus z equals to 2. X plus y plus z equals to 3 कर लेंगे. And x minus 2y minus 3z equals to minus 4. Fine. So now the question is solve using matrix method. So it will be matrix 1, 1, 1, 2, 1 minus 1, 1 minus 2 minus 3 multiplied by x, y, z. And what do you get? 3, 2 minus 4. Now this is your a, x equals to b. So x is what? X is a inverse into b. That is adjoint a upon determinant of a into b. Yes or no? Now to get adjoint of a. See, the a given to you is 1, 1, 1. 1, 2 minus 1. Sorry. 2, 1 minus 1. 1 minus 2 minus 3. Now make the matrix C whose entries are the cofactors of the entries of this matrix. See carefully. Cofactor with respect to 1. -3, -2, -5. Now, cofactor with respect to this. -6 plus 1. -5 and 1 minus we will apply the +5. Now cofactor with respect to this. -4 -1 -5. Now cofactor with respect to this. -3 +2 -1. और एक माइनस हम लगाएंगे, इट विल बी +1. फाइन. Cofactor with respect to this. -3 -1 -4. Cofactor with respect to this. -2 -1 -3 and 1 minus we will apply. +3. Cofactor with respect to this. -1 -1 -2. Cofactor with respect to this. -1 -2 -3. 1 minus we will apply +3. And finally, cofactor with respect to this. 1 -2 -1. Now, verification. See, elements of first row, cofactors of first row. What is the value? Product key -5. Then elements of second row, cofactors of second row. It is 2 -4, 2 -4 -3, -7 + 2 -5. Elements of third row, cofactors of third row. -2 -6 -8 + 3 -5. That is also fine. Now what is adjoint of A? C ka transpose. So it is -5 5 -5 1 -4 3 -2 3 -1. Correct? So A inverse is what? Adjoint A upon determinant of A. So this is your adjoint upon determinant of A k -5. Now X, which I have taken XYZ, is basically adjoint A. And now see directly I'll write inverse A into B. So it is -1/5 of inverse हो गया multiplied by B. B is what? 3 2 -4. First row, first column. -15 + 2 + 2. -15 + 2 + 2 -11. Second row, first column. -15. 15 -8 -3. So it will be -4 + 4. -15 + 3 + 1 4. This is also 11. एक second. There's some mistake with the answer. 1 1 1 2 1 -1 1 -2 -3 -3 -2 -5. Anybody seeing any mistake here? Please let me know. C inverse -5 plus 1. -2 -6 -8 plus 3 5. Determinant is correct. B is 3 to -4. This is what -4 is. 3 to -4. First row, first column, -15 plus 2 plus 8 -5. For second row, first column, 15 -8 -12 -5. -15 plus 6 plus 4 -5. So this is basically 1 1 1. So if you compare, x is 1, y is 1, z is also. Have a look. Lakshmi, understood?
Yes, sir.
So what all we have done today, we have done a property. Properties of adjoint, where A into adjoint A is determinant of A into In is adjoint A into A. Then determinant of adjoint A is determinant of A to the power n minus 1. Adjoint of AB is adjoint B adjoint A. Adjoint of ABCD is reversal law of adjoint applied. Now if A is a square matrix, then adjoint of adjoint A is determinant of A to the power n minus 2 into A. Fine. Now determinant of adjoint A is determinant A to the power n minus 1 square. So if this adjoint is repeating k times, then this is determinant of A to the power n minus 1 to the power k. Now inverse of a matrix. So two matrices A and B are called inverse of each other if AB is identity matrix, that is also B. So in that case, A inverse is B and B inverse is A. So A inverse is adjoint A upon determinant of A. Correct? Some properties of inverse equation, and then we have seen how to solve the system of linear equations using matrix method. You just go through go through it once again. We will do about 2 or 3 more questions over it in tomorrow's session. All right. Anybody having any doubt? Yes, anyone? So that would be all from my side for today. And revise your notes. Practice now. You can practice questions from any exercise of the NCERT. So make sure you complete your NCERT today itself. All right.